Welcome to part one of the Reflect webinar series. Us have been in the consulting business for a lot of years around the BI, ETL, data warehousing sphere. And what we built in the product that you'll see today is really sort of based on all of the experiences that we've had over those years and trying to build sort of a better, smarter tool to enable people to move data seamlessly from all the various different platforms that are out there. So what we like to think of it as, if you look at the traditional ETL projects that are out there that you guys are experienced with, they really take months to set up and to develop in terms of just moving data and getting all the pieces in place. And with Reflect, the product, we wanted to let you be able to build production-ready data pipelines within days without really having any kind of compromises in the functionality and the flexibility. So we set out to do that by basically tackling these four key design goals. First off, we wanted to automate the integration for rapid data ingest, meaning you take the most basic scenarios of moving table A from one system and putting it into table B for a staging purposes. We felt like that should be fully automated, point and click kind of interface. No coding required, no work to be done on either the source or the target to make that happen. Then we wanted to build in seamless support for the new modern emerging data platforms. So a lot of ETL tools that we worked with in the past, Informatica, Oracle Data Integrator, they don't really keep up, or they're very slow to be able to have the capability to connect to, source from, or write to things like Hadoop and HDFS, Redshift, Snowflake. We wanted to build all of that seamlessly in so that you can do anything that you can do in Oracle or SQL Server, you can also do in Redshift or Snowflake or Hive, and moving data amongst those is just as easy as doing it into Oracle or any of the more traditional RDBMSs. We wanted to build a simplified user interface to sort of enable data self-service. This is built around an idea that there's a lot of guys out there in the community that want to build their own data pipelines. They want to pull data from sources, put it into an analytic sandbox, and today they have to either call into their IT departments and have them do an ETL project, or they have to learn some complicated GUI and complicated tools. And so we wanted to build a tool where moving data was simple enough that people could get in and point and click without really having to learn any kind of exhaustive, complicated tools. And the last goal is we looked at what we saw in Informatica and ODI and all these other things, and we saw that for the most part, they generate really bad code. So you'll go into Informatica or ODI and you'll create this really complicated mapping. And in the end, it won't do exactly what you want, or it won't perform the way you want it to perform. And so what most talented data engineers end up doing is going in and creating SQL qualifiers and other tricks to work around the tool, essentially defeating the purpose and the investment that people were making in proprietary tools like Informatica. So we said, let's not do that. Instead, let's have people invest in their SQL skills. Let's give people an interface where they can do any kind of transformations and any kind of complexity that they want to do beyond the straightforward incremental or full refresh mapping in SQL, so that they're investing in SQL skills rather than in being the best Informatica team or having having a whole army of SSIS consultants at their disposal. We built it so that it's on-premise or in the cloud. A lot of our competitors out there in the market that have built new sort of modern ETL tools are doing them strictly cloud-based. And this creates a lot of problems in scenarios where people want to do bulk data movement on-premise. They want to put data from all of their various on-prem source systems into like a Hadoop cluster or a data lake. They don't really want a scenario where the data has to leave their environment, go out to the cloud, be processed, and then pushed back down to their environment. So in those scenarios, Reflect can run on-premise. We can also be a push then. We can run on-premise and push up into the cloud. And you can deploy on AWS or Azure in EC2 compute nodes. And so you can have an all cloud-based architecture if you want to run that way. From a product perspective and sort of underlying the technicals, there's really three major components to a Reflect implementation. There's the web-based interface on the front end, which you guys will see today. There's on the back end a metadata repository that stores all of the mappings that you've generated, all the details about how source A is connected to source B, and a lot of the lineage and history that you've generated as you move data from source to target. That Reflect server also contains a scheduler. So we have a built-in scheduler, and it also contains a whole series of logging facilities that write out log files and capture all the traffic that's occurring on your servers. It's built on what we call an agent-based architecture. So it's similar to Oracle Data Integrator. It has agents that run, and those agents do specialized workloads. They either run a map, or they extract data from sources, or they run a workflow. And the value here is that the agents allow you to scale up and across a lot of servers. So you can, if you have a very large server, you can add many Reflect agents to that server and balance the load across it. Or if you want to have multiple servers in your environment, you can also scale up. And one of the really interesting scenarios that this allows for is dynamic scaling. So in a cloud-based environment, if you have, say, like a weekend batch load that you know is going to run and it does a lot of heavy lifting, you can, through your DevOps processes, scale up and add multiple Reflect nodes, have the agents running there, push data from source into target, and then scale back down. And then that saves you a lot of money and a lot of time. You add that extra power, bandwidth, and I/O, but you're not paying for that unnecessarily when you're no longer using it. From a scalability perspective, like we said, if there's agent-based execution, you can distribute across those multiple nodes. It lets you have that dynamic scaling. From a security perspective, we leverage the security of the source systems. So for the most part, we're streaming data. We're not storing data. So as data flows through an agent, it's being streamed from a source into a target. So whatever access your connection has to source data is what you'll see, and whatever abilities you have on the target side is what you'll be able to do in terms of a write. So very similar to ODI or Informatica in terms of how we manage the security controls across the mappings. We've also integrated LDAP and Active Directory. So you have Reflect users that are built into the system if you want, but you can also turn that off and turn on LDAP or Active Directory integration. And in that case, you'll very much like OBIEE will map your Reflect role to a Active Directory group, and that'll determine what users can access what functionality or data inside of Reflect. We got certified on Hortonworks. So we achieved the certification about midway through last year. We're certified up to Hortonworks Data Platform 2.6 now. which is their latest production quality release. Obviously, we're capable on Cloudera and MapR as well, or a standard Apache implementation. We do some stuff that's a little, I think, smarter than the average ETL tool. We take the data and not just write it to HDFS, but we also go ahead and build the Hive tables and the Hive metadata for you in the system as part of it. So when you move data from your regular ERP source system and you try to put it into Hortonworks, it's not only landed in Hive, but it's or not only landed in HDFS, but it's also fully available in Hive for you to go ahead and start querying on and using right away. Questions about that
Jerry,
stuff?
do you guys do that? You guys do that with traditional like Oracle, say Oracle to Oracle. Will you create the Oracle tables as well?
Yeah, absolutely. So one of the parts of the automated process is for you not to have to create anything on the staging side ahead of time. So we all know with tools like Informatica or ODI, you have to build the model on the source side. You have to build the model on the target side, not just logically, but physically. You have to go in and pre-create those tables quite often, depending on the tool. We do all of that for you. So when you choose a source system table from Oracle and you pick a different schema on the other side, it will automatically generate all of that for you. It'll generate the tables. It'll generate all of the underlying infrastructure that you need. You can disable that. You have the capability, if you already have it built, to not have us build that for you or to match the data that's out there, but we automate the process for you. So just some other use cases that you guys might run into that we see, that we talk to a lot of customers about. When we're looking at this sort of data lake environment that's out there today, we see a lot of companies going toward this model of loading bulk data into this raw space, creating a data prep environment where they refine that data, and then ultimately building an access layer on top of that they let their data scientists and power users get at, and their business intelligence users get at. And there's a lot of places here where Reflect plays in terms of moving data into the raw space, but then also taking data that's in that raw space and refining it via custom SQL into those other data structures like dimensional models or summary aggregates that you would move along the way.
So Jeremy, in terms of like how you use Reflect between like raw space, data prep, refined space,
yeah.
Like is the approach or workflow that you kind of use Reflect to bring it into raw space, and that's one set of mappings, and then you take the data that's in raw and basically kind of jump to data prep? Or is, I guess, kind of how the image is breaking it out, it seems like it's three basically like different mappings altogether straight from Reflect to the source. Is that my question making sense?
Yeah, it does. The drawing doesn't do justice how the workflow kind of flows, but I think when you see the demo, you'll get a better idea. But you have a pure ETL framework, meaning Reflect can be man in the middle, where data comes from a source system, processes through the Reflect server, and lands in the raw space. But then we have the capability to pull the data out of the raw space, put it back into Reflect, process it through some logic, and put it into the data platform again. We also have the ability to leave the data in the raw space, process it on the target, and move it to the data prep space. And that's more of an ELT style transaction. It's just a little different in how you implement the workflow. So we can kind of talk through that when I show you the actual examples live of what would be different in moving it that way.
Things that the ETL, the leading ETL providers kind of do to distinguish themselves, or talk about themselves is their ability to have quote unquote pre-built connectors to many of the key data sources. So it's got a two-part question. One, what is your opinion on that, and then how does your product kind of deal with that and support, I guess, the ease of use of what they're selling. We all know that some of those connectors are just what they are, but I'm just curious what your opinion and thoughts are there.
Yeah, so we built Reflect with the mindset toward making those connectors powerful and making them do all of the heavy lifting for the end user, an important part of what's being done. So, we have connectors for everything from Oracle to Salesforce, and it's a growing list. That's where we spend a lot of our efforts today in terms of development. I think Chad is mostly working on building new connectors with the team, and we're constantly adding new connectors based on customer requests. We just did Google Analytics connector, but it's more than just building a connector from the read side. It's also what can be done then from the write side, and how do you enable that and make it so that data from Oracle can be pushed into data from Redshift, and that can be done seamlessly. And there's an intelligence about what a data type in Oracle means and how that data type is translated in Redshift, and how you can sort of automate those processes in selecting the right data types and doing the right data mapping. So we're investing a lot of time in building more and more connectors. The framework was designed so that building connectors and adding them is very easy. So typically, if you look at like an API-based connector like Salesforce, that usually takes our development team about 2 weeks to put together end to end. So if you came up with a new one tomorrow that you had to have, we would probably have it ready in about 2 weeks. Okay. If you have a RDBMS-based data source, it's probably about a 1 week effort. So it's even easier if it's a more traditional RDBMS source. So we've covered, I think, 90% of the market in terms of what's out there. We continue to add more and more API-based connectors all the time because those are a little more specialized and have a little more work to be done in terms of the capabilities.
One of the things that we're facing a lot nowadays is these closed cloud systems.
Yeah.
And the Oracle applications, they only allow you to push the data as flat files to two places. And one of them is the Oracle Content Management Server. There is a series of Java libraries that you can run on a on-prem server to pull the data down. How would that work? How could we run basically it's a parameterized script that we wrote in a shell script to be able to pull data down from the Oracle Content Management Server. But there's also some web services calls you can do. How do you guys handle those types of, right now we built a custom ODI component. How do you do that?
Yeah, so I think in similar fashion to what you're talking about, if it's a one-off for this one project, our professional services team can help you build a custom connector. If it's web services based, it's really not a problem. We can just use web services API calls to pull that in. If you need to execute a Java program, that can be done as well. So one of the things that's built into Reflect is the ability to execute JDBC, generic client calls. But in general, if you can get back a list of objects from the server, and those objects, essentially equate to data tables at some point, we can build a connector around it. We just need to know the specifics, and we can develop any of those.
Okay, thank you.
Mm-hmm. Gets to the last couple things here, and we'll get to the demo. this process of building data warehouses that each and every one of you have probably been through at least once in your lives now and are doing on an ongoing basis. We think there's an important methodology that Greg talked about at the beginning of the call, and that's this idea of staging the data from the source systems into a centralized area, and then taking that stage data and converting it into the facts and dimensions. And what we've done in Reflect, obviously, is automate that stage load process. So instead of, if you have 900 tables to move, instead of taking 900 hours to do that in SSIS or to do that in ODI, we completely automate the process, point and click. Your 900 tables will be done within a few minutes, and all of the data can start flowing right away into the target system. Then you can spend your time and effort on the high value work, which is building the more complicated facts and dimensions in your environment. We talked a little bit about APIs and RDBMS sources. We also support file-based sources, so CSV, log files, all different kinds of data, delimited formats. We also write out files in some particular formats. We support Parquet and Avro for writing of files, especially when you're in that Hadoop and HDFS environments. The ability to put those out in compressed formats allows you to really deal with large volumes of data, and those Parquet and Avro formats are a little more self-describing than a typical file format. APIs like random Java or RESTful APIs or any kind of sort of proprietary API environments, we're absolutely capable of building connectors around those if we already haven't. So it's just a matter of looking at the particular situation and then building those pieces out.